Hi, my name is Gabriel. I'm based at UCL, and today I'm going to present our work on the evaluation of uncertainty-aware multi-software ensembles, specifically for hippocampal segmentations. The authors have no competing interests to declare. Hippocampal volume changes are associated with neurological diseases such as Alzheimer's and epilepsy, and accurate volumetric measurements can function as a biomarker for both the diagnosis of the disease as well as the disease monitoring. The current gold standard is for manual segmentations to be performed by an expert. However, the problem is that they are very time consuming as well as prone to intra and inter-reader variability. The solution to those are automatic segmentation pipelines. However, they often lack a method to identify uncertain cases that can be then escalated to a human. Here's where reliable uncertainty estimation comes in, which can increase the trustworthiness of these algorithms by identifying the uncertain cases. The goal of the current research is threefold. First, we are going to show our work on benchmarking 5 existing tools for hippocampal segmentations. Second, we're going to evaluate different methods of integrating the predictions of the ensemble. And the third goal is to evaluate the uncertainty estimation and the calibration of the uncertainty estimation for the goal of performing quality control. The 5 segmentation methods that we used were ASH, HippoSeg, FreeSurfer, FastSurfer, and InnerEye, and we evaluated them on data from the ADNI dataset, 30 participants, then 8 patients from a local epilepsy dataset, and another 21 patients from a local dementia dataset. We quantified the uncertainty as sample variance, mutual information, and predictive entropy, as can be seen in the example on the bottom right. We used the Friedman tests with Homburg-Ferroni correction, and the region of interest was defined as the union of predicted segmentations from the ensemble members. We evaluated those 5 methods in our benchmarking with regards to 2 metrics. First, of course, the DICE score, which is here depicted on the y-axis, and then also on CO2 emissions. So in 3 colors, you can see in red the individual methods, so their performance outside of an ensemble. Then in the blue dots are ensembles with all possible combinations of triad ensembles were tested from the total of 5 methods. And then in the green dot on the top right is the full ensemble with all 5 methods. And what we find is that in experiment 1, where we just did the benchmarking, as I just said, is that the ensemble consisting of InnerEye, FastSurfer, and HippoSeg matched the accuracy and the calibration, the uncertainty calibration, of the full ensemble, while at the same time cutting the CO2 emissions by about 70%. In a second experiment, we tested different ways of integrating the predictions of the ensemble members and find that simple mean averaging yielded the highest DICE performance across all datasets. In the third experiment, we looked at using the uncertainty to identify highly uncertain cases and find that entropy is the most useful to identify those silent failures. We then assessed how well the individual methods uncertainty as well as the ensemble-derived uncertainty is calibrated, and we find that the averaged probabilistic outputs of the individual methods are the best calibrated, as can be seen in the black line on the figure. In summary, the ensemble consisting of InnerEye, FastSurfer, and HippoSeg performed best while also minimizing resource cost. And entropy turned out to be the most useful uncertainty metric to identify silent failures. Limitations of the current work include that we only evaluated 5 methods, and when looking at the CO2 footprint, we did only account for inference cost. Future work will be focusing on the robustness of uncertainty-based failure detection, especially under domain shift and in lower quality clinical scans. Lastly, I just want to acknowledge our funders and say if you are present this year at the Unsure workshop at Micallef and you work in anything related or you have a question, then just come to my poster. We can have a chat. Would be really nice. Yeah, and if you're not there, then please reach out by email. I'd be very happy to chat online also. Yeah, bye.